Hello, and welcome to Astronomy 100. In this segment, we're going to continue our discussion of the moon. And in particular, we've been describing some of the surface features that you find on the moon. Remember, some of these features you can't see unless you're looking through a telescope. And we've already described the craters of the moon, how the moon has been impacted by objects over many, many years to leave the holes in its surface. So let's go ahead and get started. In this segment, we're going to describe another of the surface features of the moon, and you can see in this picture here, they're labeled, and we'll come back to those labels in just a minute. But when you look at the moon and look at its surface, you'll notice that there are some very, very bright areas, and then you can see some noticeably dark areas. And these dark areas are what we call lunar maria. And we'll come back to the term in just a minute. Here's a close-up of one of these areas. The one thing I want you to notice is that they're very smooth compared to the surroundings. And they are also very dark compared to the surroundings. There are a few craters here and there. Now, many, many years ago, when Galileo was first looking at the moon through his telescope, he was a little sort of mystified by these smooth, dark areas. And so he mislabeled these as being bodies of water. They do kind of look like bodies of water. Imagine a very large lake, smooth water with the lake shore. But as the telescope got better and better, it was understood that these are not bodies of water. But the word stuck, and so the name mare is the Latin word for sea, and then the plural, it looks like Maria, but it's pronounced Maria. And so these are called lunar maria, or the seas on the moon. So we now know they're not bodies of water. Clearly, you can't have craters in bodies of water. Obviously, the craters would disappear. But the name has stuck over all these years. And if you look over here to the right, you can see some of the larger lunar maria and the names that go with them. For instance, there's Mare Crisium, Mare Tranquillitatis, Mare Serenitatis. And again, Mare Tranquillitatis translates into Sea of Tranquility. And then Mare Serenitatis means Sea of Serenity. And the Mare Tranquillitatis, or the Sea of Tranquility, is of course the most famous of them all, because it was in July of 1969, right about where the tip of the pointer is, that Neil Armstrong and Buzz Aldrin landed on the surface of the moon for the first time and stepped out of their vehicle, the first two men to walk on the surface of the moon. So we clearly know these are not bodies of water, but they are needing, of course, to be explained because they are very dark in appearance. Now, I'm going to show you a couple of other pictures, and then we might come back to this one. But here's a few more examples. There are some clues in the pictures. The first thing I want you to notice is how every one of these has a border that is round. So this is clearly very circular here. You can see that there's a round portion right here. But if you look in a larger sense, you can see that this edge is also round. And then we have a round one here and a round one down here. And let me go back a slide to our larger view here. Notice they're very round. Even some of these are very large. Very, very round in their shapes. And so this turns out to be places on the surface of the moon where the moon has been hit by very, very large objects, leaving very big craters on the surface of the moon. And then these craters have filled in with lava. So let's show a little bit of how we know this. When the Apollo astronauts landed on these lunar maria, they brought back rocks, basically samples from these regions. And altogether, they brought back about 840 pounds of rocks from the various places on the moon that they landed. And these rocks were studied in a laboratory. Let me show you a picture. So here's a really good example of one of the rocks brought back from the Apollo missions. And you can see that the rock has lots of little holes in it. Now these holes are actually air holes from air bubbles that have been caused by when the rock was liquid at one point. And so it turns out that these rocks that are found in the lunar maria are lava rocks. These are rocks that are formed when a volcano erupts and the liquefied rock comes out of the volcano and then solidifies. And this is a type of rock called basalt. So this basaltic rock, here you can see somebody here on Earth holding a handful of this type of rock as a sample. Notice it's very dark in appearance, but this is also rock that is formed from liquid lava, or liquid rock in this case. And even though we know that the moon does not have a very, very big volcanic history to it, we do know that this does come from liquid rock that's a volcanic process. And the way that it works, that we now understand, is early in the moon's history, the interior of the moon was still liquid. And so if you go deep down below the surface, it would be molten rock. And any object that slams into the moon and creates a big enough crater is going to damage the moon or gouge it down deep enough with the impact that it will fracture the surface of the moon, allowing the liquid rock or the lava to fill the crater. And when the rock, of course, the liquid lava, fills the crater, what we have here is that it is a very smooth liquid surface, which is of course going to be smooth just by the nature of it being liquid, and then eventually it solidifies. And so you ended up with a flat, dark area, which is again basaltic rock. Now any subsequent cratering, anything that hits the surface of the moon in these regions will leave craters on these dark areas. So in terms of geology, we know that the lunar maria are some of the youngest rocks on the surface of the moon, meaning that this rock formed after the formation of the moon, and the surrounding areas are quite old. And so that's why they seem to be covered with more craters, because that was an era when the moon was being hit by more objects when the solar system was much younger. The objects that hit the moon have been swept up over time, and so not as many things hit the moon today compared to the past. So we can actually date the various parts of the surface of the moon. The parts that have lots of craters are older than the places that have less craters, and of course it's related to the overall history of the moon itself. So the moon's surface has craters, and some of these craters were big enough to create lunar maria. Even though they're still called seas, they are clearly not bodies of water. Now this leads me to my next idea, related. One of the things that people don't necessarily realize is how very dark the moon is. We're used to going outside and seeing the moon as a fairly bright object in the sky. On the night of a full moon, you could go outside and you can walk with the light of the moon. You don't need a flashlight. So the moon, obviously to the eye, looks very bright, and it's just synonymous with being something very bright in the sky. But it turns out the material that the moon is made out of is actually quite dark. And this brings us to a definition. Let's go back to our screen here. The word is albedo. And albedo is referred to as the amount of light that is reflected from a material. So think of it as albedo is sort of the reflectivity of a mirror. An example is a mirror would be an albedo of 100% if you could reflect every bit of light that hits the mirror and bounce it back. An albedo of 0 would be something that's utterly black, where no light reflects off of it whatsoever. The moon has an average albedo of anywhere from 11 to 14%, which means that the moon is actually very, very dark. Its material is darker than people realize. I've chosen this picture in particular, again from an Apollo mission, where you can see how very white the astronaut suit is, and of course some of his equipment, and look at how very dark the ground is in the region surrounding where this vehicle is parked. So the moon actually has a surface material that is quite dark, and it's because it is made again from, in many cases, it's made from volcanic rock that was at one time very dark basaltic rock. The parts of the moon that are very bright happen to be where this rock has been broken up. Objects hitting the ground over and over again kind of pummels and makes the rock into a powder. And this powdery material that's all over the surface of the moon has a different albedo to it. It reflects light differently. It almost looks like white baby powder. But to show you just how dark the surface of the moon is, let me show you a couple of interesting photographs here. Both of these photographs are of the astronaut Gene Cernan. He was an Apollo 17 astronaut. He is, at this moment, the last man to walk on the moon. He was the last one to get in the spacecraft in the Apollo 17 mission. But I show you this because this picture was taken when he comes into the vehicle after being out and about, and you can see how very, very dark the dust is on his spacesuit. It almost looks like soot all over the surface of his spacesuit. And then when he pulls this off over his head to reveal his t-shirt underneath, he got a little bit of it on his forehead. Look at how it looks almost like I said, somebody took soot and wiped it across his forehead. So the lunar material, the surface of the moon, is actually quite dark. Its reflectivity is anywhere from 11 to 14%. Imagine how bright the moon would look if it had, of course, an albedo that was a higher number, how bright a full moon would look. Now this brings me to my last topic, and that has to do with how the moon is seen to move across the sky. When you go outside and you look at the moon, one of the things you're going to notice is its position against the background stars. So on any given night, you have constellations that are along the celestial sphere, and you will notice that the moon has a position against or in front of those background constellations. But remember, the moon is a body that is actively working its way around the Earth by orbiting the Earth. And so what happens is, as each day or night goes by, the position of the moon against the background sky is going to steadily change. As the moon is moving around the Earth, its appearance of where it is seen in the sky is going to change. And so there's a couple of ways to describe this. Let's go back to our screen here. What you'll notice is that the moon has to rise and set every day. Remember, this is caused by the Earth rotating on its axis. So no matter what the moon is doing, the spin of the Earth on its axis is going to create what we call diurnal motion. The moon rises in the east and sets in the west every day. Remember, the sun does this, the planets do this, all stars exhibit diurnal motion, rising in the east and setting in the west. However, the moon has its own orbital motion. And what this means is that if you were to go outside and find the moon against the background sky, you would notice that it is steadily working its way against the constellations. And as it works its way against the constellations in the background sky, that movement is going to be west towards east. So every single day, the moon is going to move one constellation, roughly about a half a constellation towards the east, slowly working its way along the celestial sphere. And so over the course of an entire lunar orbit, one trip around the Earth, the moon is going to go through all the constellations in its path, slowly working its way around. Now, this is confusing to people because what that means is that when you go outside and when you find the moon in the sky, it is not going to be in the same position every day, and also it is not going to rise at the same time every day. And so as the moon slowly works its way against the background sky, it takes another 50 minutes later for it to rise. So every calendar day, the moon will rise about 50 minutes later each day. If it rises tonight at 7 o'clock, tomorrow night it rises at 7:50. So 50 minutes later each day. Now this forces the moon to be out at night for part of the time, but it also forces the moon to be out during the daytime for part of the time. And sometimes people don't realize that the moon has to be out during the daytime just as often as it is out at night. During the daytime, you don't necessarily notice the moon. You might not notice the moon against the blue background, which of course makes it hard to see the moon. At night, it's a black background. But you might find if you're out and about looking around as you're doing your normal daily duties, look for the moon every now and then. You'll be surprised it is out during the daytime just as often as it is out at night. Now, the last part of this, let's go back to our screen, is that the moon is going to move about 13 degrees each day. And 13 degrees is about the width of your fist if you were to hold it all the way out at arm's length. So imagine the moon moves about the width of your fist each day. Now, as we wrap this part up, here's what I want you to notice. Notice the orbital motion of the moon, the slow movement of the moon around the Earth. If we were to time it, how long it takes the moon to complete one orbit around the Earth, it takes approximately 27 and about a third days to make one full orbit around the Earth. But relative to the sun, changing the phase of the moon, it takes 29 and a half days to complete one lunar phase cycle. So if you were to go outside and look at a new moon and then count the number of days all the way back to another new moon, you would count 29 and a half days. And what you'll notice is 29 and a half, for all intents and purposes, is practically 30 days. And so the name month, our 30-day increment that we divide the year into, this period of time is actually derived from the moon's orbital movement and its phases. The reason why the word month is the word that it is because it's the derivative from the word moon. So moon and month are actually coming from the same word. And so over the entire calendar year, it turns out there are approximately 12 lunar phase cycles. In other words, you'll get 12 full moons, 12 new moons, and everything in between all year long. And so the ancient people took that period of time called the year and they divided it into 12 increments, each one about 30 days and each one called the month. So the movement of the moon is something that's kind of tricky. I invite you to go outside and take a peek at it and look at it against the background sky. Take a peek at it through a telescope. You'll see all of these lunar features. In the next segment, we're going to start to talk about lunar phases. I hope you'll join me.